How to determine whether a relation is a function. So we're going to look at two examples here to determine whether these relations are functions. Remember, a relation is any set of ordered pairs, so both number 1 and 2 are relations right off the bat because they are a set of ordered pairs. So all we're going to do when we look at number 1 is make sure that every x is only matched to exactly one y. So for a relation to be a function, every x, or every element from the domain, can match with at most one element of the range, or of the y. So every x can only be with one y. So we look at all the x's, so we have -2, and we could ask ourselves, is -2 matched with any other y? No, it's matched with 5, and I don't see it matched to any other y. Then we could look at -3. Is -3 matched with any other y? I see 3 is matched with 5, but -3 is matched with only 6. We look at 0. Is 0 matched with anything else other than a 0 for its y? Oh, I see a 0 here. This 0 is matched with 4, and this 0 is matched with 0. So we see that that's a violation of what a function is. Every x can only be matched with one y. So because of the 0, 0, 0, 4, this is not a function. To show it another way, we often use a little diagram. So we could use this diagram to also explain the same thing. Where here I have all my x's, right, which are the elements of the domain, and all my y's, which are all my elements of the range. And one way to look at it is to kind of map the elements of the domain to its pair in the range. So I'm just kind of connecting the x's with y's. So we see -2 is matched with 5, so we could say, oh, okay, there we go. We could say -3 is matched with 6. And remember, to be a function, every x can only be with one y. Here's 0 is matched with 0. 3 is matched with 5. And that's another point, is that this is not a problem. We could have that multiple elements in the range can be matched with multiple elements in the x's, right? So y can have two x's that it's associated with. But here's where the problem happens. We have 0 also being matched with the 4. So let me put that in red. So this is the problem, is that 0 is with both 0 and 4. And I want to reiterate again, there's no problem that 5 in the range is mapped with both -2 and 3. Y's can have multiple x's. It's x's that can only have one y. So let's look at the second one. So we see that we have -1, and we're looking, is -1 only mapped to 4 and no one else? That looks true. We look at 0. Is 0 mapped to only 7 and no one else? That looks true. Is 1 mapped to 4 and no one else? That's true. Is -4 mapped to 4 and no one else? That's also true. So this is a function. And I went overkill with the 4's and the y's because we see that the y, 4, is mapped to -1, 1, and -4. And that's just to really double down on the idea that it's okay for a y to have multiple x's, but it's only okay for an x to only have one y.